We'll start with the left-hand side of this chain inequality. We'll gather all the terms on one side, so this is greater than 0, and we'll factor y from these first two terms, and minus x from these two terms. So now we can factor out 1 plus z from both of these. We have the product of two numbers is positive, so this means either both of the factors are positive or they're both negative. This gives us y is greater than x, and z is greater than -1. If they're both negative, y is less than x, and z is less than -1. Now let's turn to the right-hand side of our chain inequality, and we'll do the same thing. We'll gather all the terms on the right-hand side, so it's greater than 0. Factor out the z from the first two terms, and minus y, and finally factor out 1 plus x. And again, we have the product of two numbers is positive, so they're either both positive or both negative. So here we have z is greater than y, and 1 plus x, and x is greater than -1, or they're both negative, so z is less than y, and x is less than -1. So the left-hand side must be true, and the right-hand side. And again, if this is positive, either A is true or B is true, and for this equality, either C is true or D is true. These different options probably correspond to these disjoint convex regions, so we'll evaluate every combination, for example, A and C, or A and D, or B and C, or B and D, and hopefully one will have finite area. First, let's evaluate A and C. So from A, we get y is greater than x, and z is greater than -1. And over here, we have z is greater than y, and x is greater than -1. Combining these two on the left, we have this chain inequality. Combining these two, x and z are both greater than -1, so we can add -1 to the left of this. This looks promising as having a finite solution. Let's evaluate the other four. Next, we'll try A and D must be true. From A, we get the same thing. Y is greater than x. Z is greater than -1. From D, we get z is less than y, and x is less than -1. From these first two, we have that y is greater than both x and z. And here, -1 is greater than x and less than z. And y is greater than both of these, so y comes out here. The other part of our problem has that the sum of x, y, and z is equal to 75. We have one variable here that's x, that's going to be negative, and two other variables that are positive. So this is going to have an infinite number of solutions. This is in contrast to our first case here with A and C, where there's a lower bound on our three numbers. Let's take a look at B and C. From B, we have y is less than x, and z is less than -1. And from C, we have z is greater than y, and x is greater than -1. From these two, we have y is less than both x and z. From these two, we have that x is greater than -1, z is less than -1, and y is less than both of them. Again, the sum of these three has to be 25. We can pick any number of negative values for y and z, and then find a positive value for x that will balance them. So again, an infinite number of solutions here. And finally, we'll check B and D, combining these two. And then from these, both x and z are less than -1, so we put -1 over here to the right. Here we have three numbers that are negative, and they need to sum to 75, so it's clear there are no solutions in this case. The only case that gives us a finite number of solutions are these constraints. This chain inequality and this sum will be easier to evaluate. We'll have the same solution set if we add 1 to each part of this. So we'll replace the -1 with 0, and then we'll add 1 to each of these. And let's do a substitution. We'll let A, B, and C be x plus 1, y plus 1, and z plus 1. So now we're looking for three numbers, A, B, and C, sorted this way. With this equation, we'll add 1 each to x, y, and z, and balance that by adding 3 to the right-hand side. And then again, we'll substitute for A, B, and C. The set of all 3 points, satisfying just this second equation, we can represent geometrically in 3 dimensions, where these axes represent the values of A, B, and C. Everything contained in this triangle, PQR, satisfies this equation. This happens to be an equilateral triangle with side length 78√2. Because of the symmetry with respect to A, B, and C, 1/6 of the points in this triangle will be in this particular sorted order. So we'll find the area of this triangle, multiply it by 1/6, then that will be our answer. We'll use our formula for the area of an equilateral triangle, and we'll take 1/6 of that. Canceling all the common factors and multiplying it out, our area get is 507 root 3. The problem asks for the sum of a and b, and our answer is 510. If you'd like me to solve any other math contest problems, please leave them in the comments.